This is grounded. Okay, so this is basically the two terminals of the amplifier. Okay, and this is the amplifier, and this is its output node. And at the output, we have the resistor RL, and this node is labeled as VO. Now, prior to RL, we are going to measure VO and sense it basically in parallel and send some feedback via the resistor RO, the voltage divider, sorry, R2 and R1, the voltage divider pair. Okay, so in real life, ideally, we would have had ground, would have had the signal sent to Vn, and would have amplified the signal and fed it to the output. With the feedback now, we will really sense the output and apply some feedback component or some beta times VO into the terminal such that now really if I call this node Vf, I will have minus Vs plus Vn plus Vf equal to 0. Okay, now we typically don't study this circuit as one block, we break it. Let us look what we have here. So including RL, I will have ROF. Beyond RL, I will have the resistor R out. Okay, such that ROF is equal to RL parallel R out to R out. And from the input, for the full feedback amplifier circuit, from Vs, I will have RIF, the feedback RIF, and then beyond RS, including the whole blocks A and beta, I will have Rn. Okay, فإذا Rn is still beyond Rs, RIF is before Rs, and we know that the relation that RIF is equal to Rn plus Rs. Okay, now we know that the feedback block is this block. Okay, so this is the beta block. And we're going to start with it, and then we're going to build the modified A block. So what we studied last time is as follows. Last time we said that if I want to study the beta block consists of R2 and R1. Okay, this is port 2, this is port 1. So the first step, we solve for R11. To solve for R11, we look from this side, and since port 2, since it is a series shunt, since I'm looking from port 1, I will short port 2. And so this is R1, this is R2, this means that R11 is equal to R1, is equal to R1 parallel to R2. Okay, now the second thing that we do is we solve for R22, and this is my beta block. R22 is looking in from port 2. This is R2, this is R1. Since port 1 is a series port, I keep this here open, okay, and of course this is in line with what we said. If I have a shunt here, when I'm looking from this side, I'm going to really short this side, okay. So for R22 فإذا I look from port 2, okay, look from 2 and keep 1 open, so I will see R22 is really equal to R2 plus R1, okay. Now the third quantity that I can obtain from the beta block is as follows. I have R2, I have R1, I need to find the value beta. I have here plus minus VO and I have here plus minus VF. And this is the node that connects to the circuit. And so beta is equal to VF على VO with port 1 open, يعني left as is. So this is equal to R1 over R1 plus R2. Okay. And my beta is positive. Okay, so this way we would have finished solving the information that I need from the beta block, which are R11, R22, and beta. Now the second steps, I have to build the modified A circuit. Okay, I need to build the modified A circuit, and let us see what this means. Okay, so I'm going to remove the up amp boundary because this is really the A circuit. Okay, this was my A circuit. Okay, and this is RO. Okay, this is RO. So now to build the modified A circuit, what I really need to do is I need to now remove the beta block from both sides and replace it by its effective load. Okay, so if I redraw the A circuit, okay, so we have here the A circuit, the modified A circuit. We are going to remove the beta block. Okay, so we will remove it completely. Okay, and wherever the beta block used to exist, here at this pin, this was connected below and this was connected below. At this pin in parallel to the output, I'm going to place a resistor which is R22, and here in place of VF, and if I wanted to put a voltage VF as feedback coming from the beta block, in its place I would put a resistor R11 such that it is in series with VS and VN. Okay, so I will plug in R11, I will plug in R22, and if for those of you who did not catch it, let us repeat. I had the beta block. So the beta block was more connected as this form of feedback. This was R2, this was R1, and this was the feedback. What I do is I remove this connection here and I replace it by a resistor R22. and also I remove this connection here, but I place a resistor R11 in series with the whole VS3N loop such that a voltage builds across R1 where the VR11 plus Vn plus Vrs is equal to Vs. Okay, so it is in series with the loop, as if I'm putting a resistor so that some voltage builds in. Okay, so it is plugged in series with the loop. Okay, so now all of a sudden I have this circuit. We will now call this circuit the modified A block. Of course, we're gonna remove the beta block. Okay, and we will call this circuit the modified A block. So this circuit now is the modified A block, and the modified A block, okay, so the modified A block, it contains RS, it contains RL, okay, it contains R11 and it contains R22. Okay, so this is the input and this is the output of the modified A block. And so basically for the modified A block, we're going to call this as VI, and we are going to call this as VO. Okay, and now we want to find for the modified A block, we want to find its RI, we want to find its RO, and we want to find its gain, which is VO over VR. Great. So for Ri, if I look from here, for Ri of the modified A block, for Ri of the modified A block, it's really Rs plus Rn plus R11. Now for Ro of the modified A block, this is very important because RL is part of it. I'm going to look from here, including RL, and I'm going to set, so this includes RL, and I'm going to set Vs to 0, or Vi to 0. So if I set Vi to 0, if I set Vi to 0, this means, this is Vn, pardon me, this means that the voltage across Rn will be 0. This means that AVO Vn will be 0, and this current, this voltage here, sorry, AVO times Vn will be 0, so this will be shorted, and this is equal to 0, so this will be shorted. Okay, and therefore the resistance RO is going to be equal to little RO parallel to R22 parallel to RL. Okay, so we found the three quantities, the two quantities of the resistance. Now we are going to study what is the gain of the original circuit. So let us study the gain of the modified A block. Okay, so let us study the gain of the modified A block. So I'm just going to redraw it again. Okay, so this is I'm going to study the gain of the modified A block. So for the modified A for the modified A block, what we said we did is that we removed the VF connection and we plugged instead of it the R11. Okay, and we removed, I'm repeating so that you it gets emphasized for you. And we remove this one and we plugged in its place R22. Okay, and now the modified A block includes RL and includes VS. هنسميها VI. This is our VN and this is VO. So the modified A block is from here to here, and therefore the modified A block gain is really equal to VO over VI. Now, so we're going to find first VO over VI. This is equal to VO over VN times Vn over Vi, and Vn over Vi is voltage division, so it is equal Rn over Rn plus R11 plus Rs. Okay, and then so it is this portion, okay, here, and then Vo over Vn is equal to R22 parallel to RL over R22 parallel to RL plus little Ro times AVO. And VO is really the voltage division of AVO V. Okay, so therefore I can find from the product of those two numbers, I can find the overall modified A block gain. Okay, now from these quantities, I can find the overall op-amp feedback amplifier AF. AF is equal to the modified A over 1 plus the modified A gain times beta. I have those two quantities, so I am fine. It's A over 1 plus A beta. Okay. And now, as far as the AF amplifier, I can find also RIF. It's equal RI for the modified A times 1 plus the modified A gain times beta, and ROF is equal to RO divided by 1 plus the modified A gain times beta. Okay, so I can derive ROF and RIF from the respective modified A. These all correspond to the modified A circuit, the RI and the RO. And from this, if they ask me about the Rn of the full feedback amplifier, it's equal to RIF minus RS. And if they ask me what is Rout also for the full feedback amplifier, I will simply say that 1 over Rout plus 1 over RL equal 1 over ROF. I have this, I have this, I will solve for this. Okay, so this is the basics. I'm going to switch back now to the slides so that we can see how to follow up on this material from the slide. Okay. Okay, so now we will go back to the same problem. And in this problem, we're just going to follow up back on the slide where we stopped last time. So what we have here is the full feedback amplifier. As you see, as we said, that for the full feedback amplifier, its RIF includes RS and its ROF includes RL, and then the RN and the Rout are beyond these points. We have this is the beta block, And so we took the beta block and we studied first R11, and we said R11 is looking from here while shorting this node according to the rule. So it's R1 parallel to R2. And then we said the second thing in the beta block is that we look from for R22 from port 2, keeping this port open. Okay, and so we get R1 plus R2. And then in the last step in the beta block, we need to find VF over VO or V1 over V2, which winds up being a voltage division network. Okay, so this we covered already. Now what we look at is we look at the big circuit and we say, well, for the big circuit, I want to find the modified A circuit. Okay, so I'm going to remove the feedback, cut off the feedback from here and from here, and I'm going to plug in here R22, and at this node I'm going to draw here R11 in series. So R22 is parallel with the output and R11 is in series with this loop, and I will cut off the feedback block. I remove it. Okay, so this is the A circuit. Now this is the modified A circuit, and the modified A circuit will really start from here including RS up till here including RL. Okay, so if we look at the resulting circuit, what we will have, what we will do is we will name this node by VI to correspond to this VI, and we will name this node VO to correspond to VO. Of course, RO looks into VO and RI looks into VI, and the modified A block is with the R22 and the R11 as we explained before. This we will call Vn to avoid confusion. Okay, so this will be V. Okay, so if we elaborate the circuit as we explained this bit before, we will have a voltage division circuit at the input and another voltage division circuit at the output. We can find VO as function of VI. طبعا هيدي نسميها V1. This is mu is AVO basically. And then for RI, which is the input resistors looking into and including RS, okay, it is the resistance of this loop. The same for RO, it is the resistance looking from the output node including RL. So since when I study RO, I short the input, and if this is ground, it goes to 0, then this will be shorted and the output resistance will be the parallel of RL and R22 and RO. Okay, so accordingly I would have found A, RI, RO. Okay, once I find A and RI and RO, I have now A for the modified circuit. The same, those two are for the modified circuit. This is from the beta block. Okay, so I will use this information now, those four quantities, to find AF, to find RIF as function of RI, okay, and 1 plus by A beta, and to find ROF as function of RO and 1 plus A beta for the series shunt amplifier. And of course, I can derive Rn from RIF and RS since they are in series, and I can derive R out from ROF and RL, and these are the rules that we should use, and this is a formula, the formulas that we should use in this context. Okay, now we have here a numerical example where we are given what the gain of the op-amp is here. We are given the RID, and we are given RO and RL, R1 and R2 are also known for us, and RS. And If we plug in the information, we'll obtain the modified A gain to be 6000 here, and we will obtain beta Ri, and then we will calculate the AF, which is much smaller, which happens to be much smaller than A, because it's a feedback amplifier. Beta is a small number also. So 1 plus A beta rounds up to be 7, and we can calculate the gain. We find RIF, and from it we can calculate Rn, and we find ROF, and from it we can calculate R out. Okay, so starting with a load resistance which was around 2K, okay, we were able to include it in the modified A circuit, and then we found ROF, and then we found R out of the full feedback amplifier. يعني those quantities here, AF, Rn, and R out, they are for the full feedback amplifier. Okay. Okay, so as we explained a little while ago, those quantities AF, Rn, and R out, of course, and RIF and ROF are for the full feedback amplifier, يعني the whole circuit, not only the modified block, not only the modified A block, and they are derived from the quantities Ri, Ro, A from the modified A block, and of course the beta, and the quantities for the modified A block really come or include the beta block R22 and the beta block R11, okay? And of course the beta comes also from the beta block. Okay, okay, now let us look at another example. One more example for the real case. So for this example, it's a complex example, but I'm just going to walk you through it. We have a forward path from like a common source amplifier, يعني from the gate to the drain, and then from the gate to the drain, and then we have the output. There's a feedback that is where that senses the output and then places it back in series with the source node, okay, such that the Vsig and Vgs and Vf form a loop. Okay, so what happens here is that the main circuit that we are studying, comprises of a common source amplifier and another common source amplifier from the gate to the drain. And the last stage, we take a feedback via a voltage divider resistance from here to here and plug it in with the at the source node, such that if you look here, Vsig and Vgs and Vf form a loop, so it is plugged in series. If we want to look at this circuit, first let me explore what is the beta block. The beta block is the same beta block which we drew before, which is R2, R1. Okay, and so if we want to really understand how what's going to happen in this circuit, we will end up removing the beta block from here and here, and drawing in parallel to the output node the resistance R22, and drawing in series with this node the resistance R11. And so the circuit will end up looking something. I'm going to draw it now for you. The circuit will end up looking, the circuit will look like this. Let's draw it. So it is going to look like this here. Okay, so I will have the first amplifier from the gate to the drain, and the second amplifier from the gate, there is a resistor here, to the drain. This is common source. At the output, I'm going to put R22, and at node S, I'm going where the VF hooked in, I'm going to put between S and the ground. شكل هاي as if it were VF, but it does not exist anymore. I'm going to draw here R11. Okay, so now the augmented A or the modified A circuit, we can call it augmented or modified A circuit. The augmented A circuit is going to be a common source with resistance, followed by a common source amplifier, which is loaded by the resistor. And we can calculate the gain from here to here as two-stage gain, yani VO over V1 times V1 over Vs. Okay, now if I want to look at the sign of A, okay, the sign of A from gate to drain is negative, and from, again, this is G2 to D2, it is negative, so the sign of A is positive. And we have already found that beta is positive from before, so therefore my A beta is positive. My A beta is positive, which is what we want for the negative feedback amplifier, and we have studied the beta block before in the previous exam. Okay, so therefore this is negative feedback. Now for this amplifier, if A is very large, then I will end up with 1 over beta, okay, which ends up being 1 plus R2 over R1. And if A is very large, okay, since the full feedback amplifier will have gain A over 1 plus A beta. Okay, thank you.